So, imagine a health app that, well, never actually tells you to work out. It just sort of quietly taps you on the shoulder when you've been sitting in one posture for too long.
Right, and imagine thinking you could build that entirely on the front end, only to realize that iOS background restrictions leave you flying completely blind. So you end up having to spin up a whole back end just to see what's actually going on.
Yeah,
Yeah,
exactly. Oh, and imagine doing all of this in just 7 days, basically because an iPhone-only tool for this didn't even exist in the market.
it's pretty wild.
It really is. So, welcome to today's deep dive. We are looking into the architecture of StepMon, which is this side project that reveals some unexpectedly deep truths about building systems.
It's a really fascinating case study, honestly, because if you don't have an Apple Watch, you kind of, miss out on those built-in time to stand reminders.
Oh, right, the watch does that automatically.
Yeah, exactly. So StepMon was basically built to fill that exact gap for iPhone-only users across the English, Japanese, and Korean markets.
Yeah.
And, well, there's this little tree-growing game included, but that's really just window dressing.
Right, the absolute core engine of the app is that 1 hour inactivity alert. And building that requires a completely different mindset from like traditional goal-oriented fitness apps.
It really does.
Because a standard app just counts up to a goal, right? Like hitting 10,000 steps. But this is more like a smack detector for sitting too long.
That is the perfect analogy. I mean, a smoke detector isn't measuring how much clean air you breathe all day. It's just waiting for the absence of clean air.
Right. So
Yeah.
this app is waiting for the absence of movement over a sliding window.
Precisely. You are monitoring for a lack of signal. But translating that into technical execution is where things get really tricky.
Yeah.
The developer's initial plan was to keep it beautifully simple, just pure front end using the iOS BG task scheduler to handle the background checks.
Which, you know, sounds pretty logical for a junior or mid-level developer who is trying to avoid server costs. So why didn't that work out?
Well, the fatal flaw was just a total lack of observability. iOS strictly isolates and controls when a background task actually wakes up, mostly just to save battery.
Oh, so as a developer, it's basically a black box.
Exactly. If your stand alert fails to trigger, you are completely blind. You literally have no idea if your code broke or if the operating system just quietly throttled your app.
Wow. So to fix that blindness, they had to pivot and make this conscious architectural trade-off. They took on the overhead of adding a Spring Boot and MySQL backend.
Yeah, and not to add user features, but purely to monitor the system. The server's main job is just to send an APN's silent push using Apple's push notification service every 5 minutes to wake the app up and trigger a check.
Wait, but APNs can be notoriously flaky, right? If they rely entirely on the server push now, what happens when network issues just drop the notification?
So that is where they implemented this brilliant fail-safe dual design. They didn't just throw away the front-end background tasks.
Oh, they kept both.
Yeah, they combined the server-driven APN silent push with the app-driven BG app refresh task. So if the server push gets dropped by a bad network, the OS task still occasionally wakes the app. If one fails, the other catches it.
That is incredibly resilient. And the backend itself is kept radically simple, too. Like, they bypassed complex authentication entirely. No JWT, no oath.
Right, just a unique UUID and installed to identify the device. It's a highly defensive architecture. They even carry that mindset to the iOS widgets, running them as completely separate processes that call CMPedometer directly.
Oh, wow. So that way, if the main app gets suspended or crashes, the widget doesn't just display stale step data. It's smart. But if the architecture is this beautifully simple, what actually broke during development?
Well, even with all that planning, they hit 3 major technical pitfalls. First was background task duplication. Since iOS controls the timing, those refresher requests can queue up and then just all fire at exactly the same time.
Ah, creating a massive alert bomb. Not exactly great for a quiet health app. How do they diffuse that?
They had to build logic to check for pending tasks and add a strict 15-minute manual guard, so the app actively ignores duplicate checks.
That makes sense. And what about that APNs dependency? You mentioned those push notifications can be unpredictable.
Yeah, that was the second hurdle. APN's token expiration is basically non-deterministic. Sometimes Apple's server throws a bad token error for a perfectly valid active device.
Wait, really? So if you delete that user's token from your database on the first error, you just permanently break their alerts?
Exactly. They had to implement a 5-fail retry logic to just absorb Apple's unpredictability. You literally have to distrust the system's own error messages.
That is wild. And the third pitfall.
It's a silent killer involving Apple's privacy layers. HealthKit and CMPedometer actually have split permissions. If a user denies one of them, the system doesn't necessarily crash or throw a loud error.
Let me guess, it just silently fails and returns 0 steps.
You got it. And if you don't build explicit fallback logic, your app will think the user is sitting still when they're actually out for a run.
That really highlights how much hidden complexity goes into something so seemingly basic. So, to wrap up, I think there are 3 core takeaways for you listening today. First, the immense difficulty of engineering a stably simple system.
Right. And second, that conscious architectural trade-off of adding a backend strictly for observability versus staying purely front-end.
And finally, just the builder's attitude. If a tool doesn't exist in the market, you just have to build it yourself.
Exactly. Even a 7-day side project can force you to solve some pretty complex architectural puzzles.
Which leaves you with a question to chew on today. What simple missing tool in your own daily life is waiting for you to build it using a robust, fail-safe architecture?